Today we're going to do section 6.3, which is the law of cosines. So last time we learned law of sines. The law of sines is really good for finding sides and angles that are missing, but it only works when you are given a triangle and you are starting off with at least one angle with its opposite side pair. So if I don't have that initial like side and angle relationship pair, we can't use law of sines. We don't have something to start with. So that's where law of cosines will come in. So triangles where this will happen are going to be your side, side, side triangles, where you're given 3 sides but no angles. We wouldn't be able to use law of sines on those, so we use law of cosines. Or a side angle side, where we have a side, one angle, and then the next side. Again, we don't have a pair of an angle on its opposite side to do law of sines. So that's where law of cosines comes in. So when we do law of cosines, the nice thing is there's no ambiguous case. So we don't have 2 triangles to check for like we did with law of sines and a side angle triangle. But when you do law of cosines, depending on the type of triangle you have, the steps are going to be a little bit different. So I have these written out right here. When you are given a side, side, side triangle, so you're starting off with 3 sides and no angle, you're going to use the law of cosines to find the largest angle first. But then when you have a side angle side triangle, you're going to use law of cosines to find the side opposite the given angle. And then once you do that, you actually don't need to use law of cosines again. You're just going to then use law of sines, since you'll have a pair. You'll have an angle and side pair once you do this. So then you can use law of sines to find the smaller angle. So we have to kind of go in order here of the 2 angles given. So just be careful with these steps, that when you're going through, you're following the order of how to find the sides and angles, depending on if you have a side, 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 or a side angle side. So what is the law of cosines? So the law of cosines, again, we're going to have our triangles with A, B, and C, where A, B, and C angles are going to be capital letters. And then the opposite side from the angle will be the lowercase letter. So angle A, opposite side is lowercase a. These are the formulas depending on what you are starting with. So we kind of have 3 different versions coming from the 3 different sides and angles. So we have a squared equals b squared plus c squared minus 2bc cosine of angle A. Kind of a long one, right? And then it will switch and the letters will rearrange so that we have b squared equals a squared plus c squared minus 2ac cosine b. And then c squared equals a squared plus b squared minus 2ab cosine c. Okay, I know those equations look a little intimidating at first, but let's look at an example, and I promise they're not too bad. So when you are first approaching a problem, just like last time, I want you to first decide what type of triangle you have. So here I see we have a side, angle, side. So the SAS triangle. So remember, we have different steps to follow. So if I have a side, angle, side, I want to follow these steps here. So I'm going to use law of cosines to find the side opposite the given angle, and then find the smaller of the 2 remaining angles. So if I'm given this angle here, we want to find this first side right here. Once I do that, once I find side A, I'm going to have a pair. I'll have angle A and side A. So then we can use law of sines, which is easier to solve with. So that's kind of our goal, is to get a pair like that. So let's find side A. So since we're starting with angle A right here, to find side A, that's what we're looking for, side A, we want to use the top equation since it has a squared and angle A, which is what we have. These 2 equations won't help since I don't know what angle B or C is. So we want to use this top one. So I'm going to find a squared equals b squared plus c squared minus 2bc cosine of angle A. Okay, so that's our formula. Usually one of the problems that I see students make is that they're used to using sines, and so they use a sine instead of a cosine. But remember, we're doing law of cosines, so we need the cosine. So what you're going to do is just plug in the numbers that you do know. So I know this 12, 38, and 16. So if this is angle B, this 12 would be little b, and if this is angle C, 16 is going to be side C, and then we have angle A. So the nice thing is we actually know BC, BC, and A. We can just go plug everything in. So A squared will equal B squared, which is 12 squared, plus C squared is 16 squared, minus 2 times 12 for C, times 16 for B, cosine of the angle, which is 38. So we were literally just going to plug that all in. And then since we do know everything here, there's nothing on the right side that we need to solve for, we can literally just plug this entire thing into your calculator. So I told you it looks scary, but it's really not too bad, right? So if I plug this in, we're going to have 12 squared plus 16 squared minus, and then I usually do this whole thing in parentheses right here so that the calculator doesn't mess up any of the multiplying. So I do parentheses 2 times 12 times 16 times cosine of 38, and then close the parentheses. So we want to subtract that whole group right here. And we get this 97.403. So again, I put parentheses around that whole thing. So this equals 97.4038 ... But this equals a squared, not a. I'm just wanting to find a. So we have one more step. I need to get rid of that square by square rooting. So I'm going to go in my calculator and then take the square root. And I usually just go up and highlight that whole strand of decimals. And we get this. And it said to round to the nearest thousandth. So this 3 will just round down to keep 9.869 for side A. So we just found this side right here. So the nice thing is once we have this first side, we now have angle A and side A. So once I have that pair, I can use law of sines to find the other two, which finding angles using law of cosines is more work than finding a side like we just did. So if I can, I want to do law of sines just because it's going to be easier. So remember though, in our steps, once we find the side opposite the given angle, which is what we did, we then want to find the smaller angle that's left. So how do I know which angle is the smaller angle? So remember, in a triangle, the bigger the side, the bigger the angle across from it. So if I look at my two sides that are left over, this side is 12 long versus this side is 16 long. So angle C has to be opened wider to make this side 16. So that means angle B is going to be the smaller angle. So we want to find angle B next. And we're going to use law of sines now, since it's going to be less work than doing law of cosines. So remember, for law of sines, we're going to take the pair that we have both parts. So for this case, it's going to be the A's. So I'm going to do sine of angle A over side A and set it equal to sine of the ones that we're trying to find, which are the B's. Okay, so now we'll just plug in what we know. I know both of the A's. So we're going to have sine of 38 degrees over 9.869 is equal to the B's. I don't know angle B, so I'll just leave that, but the side is 12. And then, just like last time, we're going to cross multiply a whole bunch. So we're going to have 9.869 times sine of angle B is equal to 12 times sine of 38 degrees. And then we're trying to get B alone, so let's first divide by this 9.869. Those cancel. Divide it over here as well. So I have sine of angle B is equal to this lovely thing. So I usually will go ahead and just get that answer now rather than trying to keep going with that big ugly fraction. So let me just type this in really quick. And you still want to be in degree mode. So make sure you're in degree mode for your calculator. And we get this lovely decimal, 0.7486. But we still have that sign we need to get rid of. So remember, to get rid of a sign, you need to do the inverse sign. Inverses are opposites of regulars, trig functions, so they cancel, and we get b that comes out. I'm going to write it over here. But I still need to take the inverse sign of this lovely decimal. So I'm going to take the inverse sign of that 0.7486. Usually in my calculator, though, I like to keep as many of those digits as possible. So I'm going to go up and highlight that whole strand because that's going to make your answer more accurate. And since we are rounding to the thousands place, we want to try and make sure that row of decimals is accurate. So we end up getting 48.469 as our answer. Remember, this is an angle, so angle B will equal 48.469 degrees. Okay, so we just found this angle. Okay, so we now have two angles, and we just need to find the third angle. So if you wanted, you would be more than welcome to do law of sines to get angle C, but there's definitely a faster way. So if I have two angles in a triangle, isn't there an easy way to find the third? We can just subtract from 180. So that's the nice thing with the law of cosines problems, is you're only going to do law of cosines the first step. Then you have enough information, you have a pair to do law of sines for the second step. But then the third step, you can just subtract from 180. So let's find angle C. Again, I always want to do the KISS principle. You guys heard the KISS principle is keep it simple, stupid. Do the simplest method to solve that you can. So law of cosines, law of sines, and now we're just going to subtract from 180. Because that's going to be a lot faster than doing law of sines or law of cosines. So I'm going to start with my 180 degrees. I'm going to subtract the 38 that they gave us, and then subtract the 48.469 that we just found. So if I subtract those, I am left with 93.531. And that equals angle C. And we're done. So we have our missing side and then our two missing angles. So when you guys are going through these problems, though, just make sure you're following the correct order. So like again with law of sines, we needed to do the side opposite the given angle first, and then the smaller of the two angles. And also just be careful that you're labeling as you go. Another thing that I see students get marked wrong for a lot on these problems is they do everything right, but they label their answers wrong, or they type them into the wrong answer box on their homework, and then they get marked wrong. So just be careful that you're labeling the correct angles and sides as you go. Okay, so that was a side angle side. We're just going to do one more. We're going to do a side, side, side triangle, so you guys can see how to do those. So we see we have a side, side, side. I don't have any angles to start with, so I can't do law of sines no matter how much I want to, because I don't have an angle to begin with. So we have to do law of cosines. When you have a side, 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 you're going to follow these steps right here. You're going to use the law of cosines to find the largest angle first. So that means it's going to be this angle across from the biggest side. So I see I have 8, 10, 16. 16 is my biggest side, so I want to find the angle across from it, which is angle B. So we're going to find angle B first. And since we're trying to find angle B, I want to use the formula that has angle B in it. So we're going to use this middle formula, the B squared equals A squared plus C squared. So B squared equals A squared plus C squared minus 2AC cosine of angle B. And then we're going to plug in the numbers that we know. So we happen to know all of the sides this time. So I'm just going to label them to make sure we don't do anything incorrect. So this is angle A, this is going to be side A, this is side B, and if this is angle C, this is side C. So let's plug in those numbers. B is 16, so we're going to have 16 squared equals 10 squared for A squared. C is 8, so we're going to get 8 squared minus, and then I do 2 times A, which is 10, times 8 times cosine of angle B. So the sad part about doing a side, side, side is we don't have everything on this right side. We can't just throw it into the calculator like we did on the last problem. We need to solve for angle B, so we need to back solve. We need to get rid of all of this to get B alone, to just figure out what it is. So first, let's just simplify some of these squared numbers just to make our lives a little simpler here. So 16 squared is 256, and then we have 10 squared is 100, 8 squared is 64, and then we're minusing this guy. I like to multiply these three numbers first, so we get 2 times 10 times 8 is going to be 160. Remember, this number is timesing the cosine, so it's kind of stuck on the front there. Sometimes I have students wanting to add and subtract these three numbers, but we can't subtract this number when it's being multiplied to the cosine. So we do have this 164 right here. If I'm trying to solve for B, I can minus this 164 over to this side first so that those all cancel. Okay, so 256 minus 194 is going to be 92. And then that equals, we have a negative 160 cosine of angle B left over. So now we're still trying to solve for B. So I want to get rid of this number first. Again, a problem I see students make is they try to add the 160 over, but 160 is not being subtracted, it's being multiplied to this cosine, even though it has a negative. Don't let that negative throw you off. So to get rid of that multiply by 160, we need to divide by a negative 160. So careful on your algebra there. So if I do 92 divided by a negative 160, we get a decimal of a negative 0.575, and that equals cosine of angle B. And just like whenever we're trying to get rid of a trig function, we'll use the inverse of that trig function. So to get rid of a cosine, I now am going to do the inverse cosine of a cosine. Those cancel, and we get the B alone. But then I also need to take the inverse cosine of this side. So if I go and put that into my calculator, I'll do second cosine to get that little inverse cosine of the negative 0.575. And we get this lovely answer, 125. And then this 6 is going to bump up those decimals there. So we end up getting 125.1. And then since they still did say the thousandths, we need to keep those 2 zeros, even though it's kind of silly. But we want that 3 decimal places, so keep those zeros there. So this was an angle, so it would be in degrees. So we just found that this is 125.1 degrees, and that would be that angle. But just like in the last problem, once you have that first angle, you now have a pair. We have angle B and side B. So now I can switch to the law of sines rather than doing the law of cosines to find an angle, because now you guys can tell finding an angle using law of cosines takes more steps than finding a side. So I want to do law of sines if I can. So once you have that first angle, we can now find one of the other 2 angles. So let's just find the smallest angle. So if this side is the smallest side, angle C is going to be this next smallest angle. So let's find angle C next. So the formula we'll use since we're trying to find C is C squared is equal to a squared plus b squared minus 2ab cosine of angle C. All right. I'm having a brain fart. We don't need to do law of cosines. I just told you guys we can do law of sines now because that's going to be faster. So we're going to take the pair that we know, which is the b's on this one. So we're going to do sine of angle B over its side. Set it equal to the pair we're trying to find, which is the c's. And again, we want to do this. You could do law of cosines. It just will be more work on your part. So let's not do that. Let's do law of sines. So let's plug the b's in that we know. So we're going to have sine of that 125.1 that we just found over its side 16. And then that will equal sine of angle C we're trying to find over its side 8. And more cross multiplying, so we get 16 sine of C is equal to 8 times sine of 125.1. So then we are trying to solve for C. So let's first divide by 16. So those cancel and I get sine of angle C alone. Again, I like to just throw this fraction into the calculator now rather than trying to do some weird ugly thing. So we'll do 8 sine of 125.1 divided by 16, and that gives us this lovely decimal right here. So we get 0.40907 dot dot dot. But to get rid of the sine, we are now going to take the inverse sine of both sides so that those cancel, and then C will equal the inverse sine of this decimal. So I'm going to just go into my calculator and do second cosine and then, or whoa, not cosine. I'm struggling with my sines and cosines. See how easy it is to do the wrong one? It's inverse sine of that decimal. And we get 24.147 if we round to the thousandths place. So C is equal to 24.147 degrees. And there is angle C. Okay, so we just found this angle right here, 24.147. So now the only thing we have left is angle A. And just like in the last problem, you don't need to do law of sines or law of cosines to get this angle. You have two of them already, so we can just subtract these two angles from 180 to get angle A. So let's find angle A. So we're just going to subtract from 180 to keep it simple. So 180 minus the 125.1 minus the 24.147 and see what is left over. So if I do that, 180 minus 125.1 minus 24.147, we get 30.753 degrees, and that will equal angle A. And that is your answer. So now we're done. We have all three angles solved for. So that is how you'll do your side triangles. Again, just make sure you're going in the proper order for a side angle side or a side. So for the side sides, you're going to find the biggest angle first, then the smaller angle, and then the middle sized angle. And that will be the order. So hopefully that makes sense for you guys. I do have one more thing I want to look at is just when to use law of sines versus law of cosines. Okay, so law of sines and law of cosines. You want to use law of sines when you have a pair, so when you have an angle and its opposite side. That is going to happen in these triangles. You have an angle, side, angle, or the side angle. Put a little star next to that one because that's the one that has the ambiguous case where you have to check for two triangles. So it's going to happen on more ones that have more angles versus sides, and then that lovely SSA where we have to check for the second triangle. You then want to use law of cosines when your triangle has more sides given and you don't have an angle side pair. So that's going to be the side triangles and then the side angle side triangles. And just like we talked about, you do have those different steps to follow versus which triangle you have. So if you have a side, 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 you're going to use law of cosines to find the largest angle first. Or if you have side angle side, you're going to use law of cosines to find the side opposite the angle that was already given, and then find the smaller angle. So this is a really helpful little piece to remember, just to kind of organize what to do when. Because on your homework, sometimes they might not tell you to use law of sines or law of cosines. They're just going to give you a triangle and say to solve it. So you're going to need to know, when do I use which method? And sometimes that's the trickier thing to remember, is when to use law of sines versus law of cosines. So kind of the easy way to think about it is, if I have an angle on its opposite side, I want to use law of sines just because it's a little bit easier. If I don't have an angle on its opposite side, I'll probably want to use law of cosines. But as always, if you guys have any questions, please feel free to reach out to me. I'm more than happy to help you set up a Zoom call. But I hope you guys are doing well, and I will talk to you later.